we're going to talk for a minute about how to find inverse functions, not just verify them. In order to do that, let's make sure that we understand what's happening with inverse functions. For a function like this one, f of x is equal to 4x minus 2, we can plug some stuff in and make sure we know how this operates. If I plug in a 0, I'll get out a negative 2. If I plug in a 1, I'll get 4 minus 2, so I'll get a positive 2. If I were to plug in a 2, I'd get 4 times 2 is 8, minus 2 would be 6, and so you can see that I have specific inputs and outputs that are really easy to compute here. What that means is that my inverse function would need to be able to restore these original inputs based on those outputs. So if I plug negative 2 into my inverse, I would expect to get a 0 out of it. If I plugged a 2 into my inverse function, I'd expect to get a 1 out of it. And if I plugged a 6 into my inverse function, well, I know that the 6 is really just a mutated 2, and so I would expect to get the original 2 right back out of it. So if the inverse function just restores me back to the original, you're kind of noticing that all this means is that the x and the y's have swapped places. That's the rationale behind the process that you all learned last year in Algebra 2, that to find an inverse function, you just swap the x's and y's, because truly, the x's and y values are just swapping places. So, what that looks like for us here and now would be that here, where it used to be f of x is equal to 4x minus 2, then we can just swap the x's and the y's, the inputs and the outputs. So over here, where the f of x was, that's now our x. And over here, where the x used to be, that's now our inverse function. And we're treating this entire expression as if it's just one variable. So even though it's a lot of different symbols, f, negative 1, parentheses, x, and parentheses, we're still treating it as though it's just a variable. And we're going to do the algebra the same way we always would. So step 1 would be to add 2 to both sides. And step 2 is going to be to divide both sides by 4, which means that my inverse function is going to be x plus 2 divided by 4. That's pretty straightforward. And one of the ways that you were taught was using y's instead of this. That's okay, but the naming convention here is really specific. It basically shows this and this are not the same thing, but they are related. And so knowing, okay, they're not the same thing, but they are related is really important and really precise. That said, if you want to be really clear about what y means to save yourself some of the hassle, you can. So let's give ourselves a shorthand for this more complicated function, and that way we'll be able to do it without having to think over and over and write g to the negative 1 of x, because it's going to be in there a lot. So I'm going to start this problem by simply declaring that for the duration of this problem, y is going to be equal to g negative 1 of x, which means that every time I use y, I'm just using a shorthand for this longer version of the function. And then in the last step, I'm committing to swap it back out. That way I have the more focused and clear naming convention of a function and its inverse. In this function, what that looks like, then, to create the inverse, is the left side is no longer g of x. It's now x. And the right side is no longer 2x plus 4, it's 2y plus 4 over 2y minus 3. From here, it's just a series of inverse operations. First thing that I'll do is multiply both sides by 2y minus 3 in order to cancel out the denominator. So on the right side, that divides out to 1. On the left side, I'll distribute that. This becomes 2xy minus 3x, distributing the x to both terms. And the right side becomes 2y plus 4. Then, if I'm solving for y, for my inverse function, what I'll do is get all the y's on one side. I'll do that by subtracting 2y and adding 3x to both sides. So minus 2y plus 3x. I'm really good at doing this in my head. If this is confusing to you, watch it again, see if you can figure it out. So this left side becomes 2xy minus 2y. And this right side becomes 4 plus 3x last thing I need to do is factor out that y so that I can solve for it. So this right side becomes y times 2x minus 2. And the right side is still 4 plus 3x. In order to get y all by itself, since this is multiplication, I'll divide both sides by 2x minus 2. And that'll divide to 1 on the left, which means that I finally know that y is equal to 4 plus 3x over 2x minus 2. I have two quick caveats here. One is that we don't want to write it as y equals. We want to use our better naming convention. So a really good last step is to swap out the y for g inverse of x is equal to 4 plus 3x over 2x minus 2. This is not any different from that, but it is more precisely named, and it shows that this g goes with that g up there. The other thing worth noting is that sometimes, depending on how you do your algebra and which side you put the y's on, you may end up with a negative version of this exact same thing. Don't freak out. Remember from forever ago that negative 3 over negative 2 is the same as 3 over 2. So if you have a completely negative numerator and a completely negative denominator, and it's the opposite of what an answer key or what a given answer looks like, just know that that's normal, and that's a result of the fact that a negative divided by a negative is a positive. Cool. Watch it twice, raise your hand with questions.